All right, so now let me get back on it. All right, so we're looking at 8.4, theorems about zeros. So to find all possible rational zeros of a polynomial, we find all factors of the last number and I'll just call that P, and divide by all factors of the first number Q. So it'll be in the form of P divided by Q, and that can be a plus or minus on those, taking account the positive factors and the negative, where P is all factors of last number, and then Q, like we said, is all factors of the first number. So we'll use this in a little bit on the last few problems. They're going to have us find all zeros, and they're not going to give us any of the zeros. So we don't want to have to check every single number out there. So we can use these ratios to find numbers that we want to check. So we're going to do a problem where we find all the rational zeros of a polynomial. So we're going to find all possible rational zeros of P of X equals 10x to the third minus 34x squared plus 46x minus 21. So to find all the possible numbers that I want to look at, I'm going to figure out what my P and Q are. So my P is going to be my last number, which is my 21. So all the factors of 21 could be a plus or minus 1, plus or minus 3, plus or minus 7, and then a plus or minus 21. All right, now we find our Q. So Q was the first number, which will be 10. So I now need to find all the factors of 10. And factors of 10 can be a plus or minus 1, plus or minus 2, plus or minus 5, and then a plus or minus 10. Okay, so what we're going to do now is find all those possible zeros by taking all of these P's up here and dividing every one of them by all the Q's. Okay, so I'm going to start out with the 1. So plus or minus 1 divided by my first Q, which is 1. But y'all, 1 divided by 1, I can simplify that to just a plus or minus 1. Right now, I take that plus or minus 1, divide by the next Q, which is a 2. All right, so the 1/2, I cannot reduce any further, so I'm done with it. Then I take my 1, and I divide by the next Q, which is a 5. All right, that doesn't reduce, so then I take my 1, and I divide by the last Q I had, which was a 10. All right, y'all, that does not reduce. All right, let me put in people here real quick. All right. All right, so I did all the division by the Q's on the 1, so now I got to start with the 3. So I take that plus or minus 3, divide by the 1. That will reduce to just a plus or minus 3. Then I take the 3, divide by the 2. That one doesn't reduce. Then I take the 3, divide by the 5. That one doesn't reduce, and then I take the 3, divide by the 10. And that doesn't reduce. So we've done good 2 of the p's. Now we're taking the 7 and doing the same thing. Plus or minus 7 divided by 1 will just give me a plus or minus 7. Then I'm going to do the 7 divided by 2. That one doesn't reduce. Then I'll do the 7 divided by the 5. And then finally, y'all, the 7 divided by the 10. All right, then finally, we got our 21 is the last piece, so we're going to divide the 21 by all of our q's. So that will reduce just a plus or minus 21. Then I'll take the plus or minus 21, divide by the 2. That one doesn't reduce. Then I'll take the 21, divide by the 5. And then finally, take the plus or minus 21 and divide by the 10. So that doesn't reduce. So if I was looking for zeros on this polynomial, one of these numbers that we got written down here would actually be the zeros of it, okay? So that I wouldn't have to check numbers like 2, 4, 5, 6. Since they're not factors of this polynomial, we don't have to worry about them. Yo, that's the main thing on that. You're just finding all the possible zeros for it, okay? Anyone still writing? All right, so y'all good? All right, so doing that was getting us ready for the next problem. We're going to find all zeros of the polynomial f of x equals x to the third minus 111x plus 110. And the difference in this problem and what y'all have done in the past, they gave you a 0 to start with so that you could do your synthetic division and then you hit the quad formula on what was left. This time, y'all, they didn't give me any zeros. Now, once I find all the zeros, they want me to factor this into linear factors. And what they mean by that, they just want me to put everything in parentheses, okay? Alrighty, so first, I'm going to find all the possible zeros. So I'm going to take my P, which is 110. And on this one, my Q is 1 since there's no number in the front. All right, we also factors of 110. So if you want help on the factors, I got a program on the calculator you can use. So let me clear that. So to find factors of a number, you can hit program and go down to factor number 2. So you see it says factors 2. So I'll write that here. So you hit enter on factor 2 and get it started. We want all factors of 110. So there's all the factors of 110. It is a 1, 2, 5, 10, 11, 22, 55, and 110. Alrighty, which means my P's and Q's can be all of these factors divided by the Q. So my possible factors can equal plus or minus 1 over 1, which is just a plus or minus 1. So I'm just going to, since all these are being divided by 1, I'm just going to cut to the chase so that my factors could be a plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 11, plus or minus 22, plus or minus 55, and then a plus or minus 110. And that's because the first number is a 1, and that 1's not changing any of these numbers, okay? Now, I don't want to have to do synthetic division 2, 4, 6, 8, 10, 12, 14, up to 16 times on this. So I'm going to show y'all a trick I do. I'm going to graph this polynomial. So I'm going to go to my y equals and clear this out. And I'm just going to graph it. I'm going to graph the x to the third minus 111x plus 110. Because if you remember, the zeros of this polynomial are going to be where it crosses over the x-axis at. So if we hit graph, I can tell right there that that looks like that graph is crossing right at a positive 1. And if you want to make sure, you can hit second graph and go to your table. And let's go down here. And if you see it positive 1 here on the x's, my y value is 0, which is what I want. So I'm going to try the 1 and see what happens. So remember, we got to write our coefficients of our polynomial. So I got a 1 for the x third. Y'all, there's no x squared term up here. So since there's no x squared term, in descending order, I have to put a 0 for that place. All right, I got an x term. It's a negative 111. And then at the end, I got my number, which is a 110. So I'm just going to make a note. I had to use a 0 since there was no x squared term. Okay. All right, I'm going to draw my box. If we are right and we choose the right number, that remainder will be a 0 when we're done. All right, so let's go. We bring the 1 down. 1 times 1 is 1. That goes under the 0. Add 0 plus 1, you get 1. 1 times 1 is 1. That goes under the negative 111. Negative 111 plus 1 gives me a negative 110. And then negative 110 times 1 is a negative 110, which means our remainder is definitely a 0.
0.
So the first 0 we found is going to be that 1. Now, since we got 3 numbers left, we're going to use our quad formula. So A will be 1, B will be 1, and C will be a negative 110. So once we get down to 3 numbers over here, we can use the quad. So I'm going to go over here, clear that, go to program, and then go down to my quad. And then hit enter, and then enter again. So then we just put in a 1 enter, 1 for the B enter, and a negative 110 for our C. We hit enter, and my last 2 answers are going to be x equals 10, x equals 11. So that's going to be my last zeros, 10 and negative 11. So anytime you start out with an exponent of 3 for your degree, you got to get 3 zeros. Now they wanted them put into linear factors. So for linear factors, they're going to have the f of x equals, and then we got to fill in the rest. All right, y'all, so since we got 3 zeros for our linear factors, we're going to have 3 sets of parentheses. And all we're going to do is change the sign of the zeros when we put it into the factor. So since that was a positive 1, my first factor will be a x minus 1. Since that's a positive 10, the next factor will be x minus 10. And then since that one's a negative 11, that factor will be x plus 11. So all we're doing is we're just changing the signs when we put them into the factor form. All right, y'all, so that's everything on that. Was there any questions?
No.
Straightforward.
right, so let me break out the next one.
So wait,
Oh, y'all need to write that?
example.
Say again?
So instead of doing it the long way, which is example 1, we could just do it with example 2.
On the you say Kramer 2?
No, example 1. Like instead of doing it the long way on example 1 that you showed us, we could always find the answer with example 2 the way that you showed it. Because I missed the part when you showed us how to do I don't even know what this formula is called.
Synthetic division?
Yeah.
Mm-hmm.
Okay.
Yep. All righty, we're going to move on to the next one here is a f of x equals 2x to the third plus 7x squared plus 98x plus 343. All righty, so I'm going to find all my possible zeros because I don't know where to start on this one. So P for this one would be the 343. Q will be the 2. So I'm going to find all factors of 343, which will be 1, 7, 49, and 343. And y'all could have used the factor 2 program to get those numbers. And then my 2 only has factors of 1 and 2. So I'm going to find all the possibilities by taking all these P's and dividing by the Q's. So I could have plus or minus 1 divided by 1, which is just a plus or minus 1. Plus or minus 1 divided by 2. That doesn't reduce. Then I got the 7. Plus or minus 7 divided by 1 is a plus or minus 7. And then the plus or minus 7 divided by 2. Then I got the 49, which will give me just a 49. And then plus or minus 49 divided by 2. And then finally the 343. And then divide that one by the 2. And then that doesn't reduce. So I don't know which one of these to start with, and I don't want to do a lot of synthetic division, so I'm going to graph that again and see where that graph does. So I'm going to clear that, put in my 2x to the third plus my 7x squared plus 98x plus 343. Now I'm going to hit the graph. Whoa, that don't hit exactly on any of them points. If you notice, that looks like -1, -2, -3. So my line is in between a -3 and a -4. So what I want to do, I definitely know that that's going to be a -0 because it's to the left of the y-axis. So what I want to do, figure out which one of these fractions equals something that's in between 3 and 4. So if you divide 1 by 2, you'll get 0.5. Well, that's way up here. Oh, look at that. If you divide 7 divided by 2, you get a 3.5. And that does look like it could be at a 3.5. So what I'm going to do is use the -7/2 as my first zero. So y'all let that calculator, let that thing do the work for you, okay? All right, so I got my -7/2. We're going to have to write all of our coefficients. I got 2, 7, 98, and a 343. So this time I didn't need a 0 because I had all my places there. All right, y'all, remember that's a degree 3 since the exponent's a 3. So we need 3 zeros when we're done. If this number's right, that will be a 0 when we're done, okay? All right, so here we go. We're going to bring down to 2. So now you got 2 times a -7/2. So 2 times a negative 7 divided by 2 gives me a negative 7. So basically the 2's cancel when you multiply that. All right, 7 plus a negative 7 gives me 0. 0 times a negative 7 halves is 0. 98 plus 0 is 98. And then at this point, 98 times a negative 7 divided by 2 equals a negative 343. And y'all look at that, 343, negative 343, give me a remainder of 0. So I know my first 0 is going to be a negative 7 halves. Now, since I only got 2 zeros left and I got 3 numbers here, I'm going to use my quadratic formula. A is 2, B will be 0, and C will be 98. So let me go to Program, Quad. Now, y'all ain't gonna lie. If y'all really want to, y'all can do these by hand, okay? If y'all like that quad that much. All right, let's see what I get. Looks like I get 0 plus 7i, 0 minus 7i. So that'll just be a 7i and a negative 7i. So that my last 2 zeros are the 7i, negative 7i. So now let's put these into linear factors. So they're going to give me the f of x equals. So I got 3 zeros, so I need 3 sets of parentheses. And then I'll show you something else you have to do on this one. So since that's a negative 7 halves, this is going to make that a positive 7 halves. Since that's a positive 7i, that'll make that a negative 7i. And then finally, since that's a negative 7i, this one will be a positive 7i. Now on this one, you got to do one more thing, because since there's a fraction here, we also have to put that number down in the front of this, so that your final answer will be 2 times x plus 7 halves, x minus 7i, and then x plus 7i. Okay, so anytime you got a fraction, you always got to put that number out front also. Because if I was to FOIL this, those would actually cancel out, okay? Ooh, all right, that was close to the big one. So I'm going to let y'all have a chance to write this. And then we will end up by finding 4 zeros. And y'all know I got that synthetic division program in the calculator if you need help doing this synthetic division, okay? All right, so I'm turning page. It don't sound like no one's still writing. All right, so the last problem in 8.4 has us find 4 zeros. So we're going to find all zeros of f of x equals x to the 4th minus 10x to the 3rd minus 66x squared minus 94x minus 39. And then we're going to put them into linear factors.
Dude, we need to be working this.
All right, so I'm happy again. The first number is a 1. So all I need to really do is find all factors of my 39, which is my p. So factors of 39 could be plus or minus 1, plus or minus 3, plus or minus 13, and then a plus or minus 39. And once again, I don't want to have to do a lot of synthetic division. So I'm just going to graph this in my y equals. So let's see, I got a x to the 4th minus a 10x to the 3rd minus 66x squared minus 94x minus 39. Whoa, them get long sometimes. All right, so we want to see where this is crossing that x-axis at when I hit graph. Here we go. I got two places I could put a hit. I can get this one where it's touching that x-axis, and then I can get that one where it's going through. So this one looks like a -1, and that one looks like it's at about a -3. So hell, I'll just start with that -1 because ones are easier to multiply than threes, okay? And if you also look at the graph on the second table, right down here is -3, you got a 0. And down here at -1, you got a 0. So that's a good way to also look for numbers, okay? All right, let's write our numbers out. I got a 1, -10, -66, -94, and a -39. All righty, so if we're right, we're going to have a 0 remainder there, okay? So here we go, bring the 1 down. 1 times -1 is -1. -10 plus -1 is -11. -11 times -1 is a +11. -66 plus 11 is a -55. We got to watch these signs. -55 times -1 is a +55. -94 +55 will give you a -39. And then here we go. -39 times -1 is a +39, which gives me a 0 remainder. But y'all look at this. I'm not down to 3 numbers yet. So I'm going to have to do synthetic division again so that I can get this down to 3 numbers. So these are going to be my synthetic division coefficients. So I'm going to write down my 1, -11, -55, 9. Write my box, so that'll be my remainder. Once again, I need a 0 remainder there. So I know my first 0 was that -1. I need another number to check. And if you remember on my graph, since I tried that -1, I'm now going to try that -3. So that also crossed that x-axis, okay? All right, y'all, so here we go. We're going to bring that 1 down. 1 times -3 is -3. -11 plus -3 is a -14. -14 times -3 is 42. -55 plus 42 is what, a -13. And then that -13 times -3 is a +39. So once again, I got a remainder of 0. So my second 0 is going to be the -3. Now to get the last 2 zeros, since I got 3 numbers here, we're going to use the quadratic formula. A will be 1, B will be -14, and C will be -13. All right, so quit that. Let me go to program, quad. Enter and enter. So I had a 1, a -14, and a -13. So I don't want decimals, so I hit enter one more time, and I get my x of 7 plus square root of 62, and an x of 7 minus square root of 62. All right, so at least this one didn't have fractions to worry about. So let's put our linear factors together. Since I got 1, 2, 3, 4 zeros, which is what that exponent told me, I need 4 sets of parentheses. All right, so remember, I'm going to start with this one. Since that's a -1, this will become a +1. Since that's a -3, this will become a +3. So I'm just changing signs. So watch this. That 7's positive, it becomes negative. That radical's positive, it becomes negative. And then on this one, that 7 becomes negative, but this radical becomes positive. So I'm changing every sign when I put it down into my linear factors, okay? All right, so I'll let y'all write that for a second, and then we can move into the 5.1.
So, quick question.
Yes.
How do you find the -1 and the -3 you have on the side right there?
Oh, those are the zeros I'm getting that I'm checking from my graph. So when I go back to my graph, when I graph that, if you notice,
Uh-huh.
I'm touching right here at that -1 on my x-axis. And then over here, it's going straight through the -3 on the x-axis. So if you hit the table by hitting second graph, you'll see right here at -3, you see how I got a 0 for the y? And then I'm going down to -1 and I got a 0 for the y. That's the easiest way to do it. Otherwise, you would have to try every number until you got 0 remainders. You'd start out with a 1.
Gotcha.
See, if I started out with a 1, it wouldn't work. And then once I tried -1, it would work. But then down here, I would probably start with 3, then go to -3. So I'm doing unnecessary synthetic division when I can actually use that graph to get there quick.
Gotcha.
Hey, that makes sense?
Yeah. Because I missed that part when you did that lesson, so I was
okay,
like,
when we was doing a lot of this
on how to do it.
zero stuff. Alrighty, so the nice thing about 5.1 is it's really nothing new. 5.1 deals with rational expressions. So this first example, I'm going to find all numbers for which the rational expression is not defined. So they're giving me f of x equals 3c squared minus 10 over 12c plus 25. So this is really just like finding the domains. So if I want to find numbers for which the rational expression is not defined, I'm going to take that denominator, 12c plus 25, and set that equal to 0. And we're only concerned with the denominator. Okay, remember, because the bottom's what cannot be 0. The top can be 0 all day long, okay? So to solve this, I'm going to start out by subtracting 25 from both sides. So I get 12c equals a -25. And then finally, we finish by dividing by 12. So that c, let's see, I cannot reduce that, is going to equal -25 over 12. So the only number that this expression is not defined for would be -25 over 12, because when you put that in for the c, the 12s cancel, and then the -25 plus 25 would make that 0. Okay, so this is the stuff that sort of got you ready for doing the domains. So the new part of this, x squared minus x minus 1 over x squared minus 14x plus 45. So the only thing new in this section is that we're putting quadratics on the bottom instead of just single variables, okay? But I'm going to do the same thing. I'm going to take that bottom, x squared minus 14x plus 45, and set it equal to 0. Now, I'll probably factor this. Since this is a quadratic equation, you could use quad formula if you wanted. Okay? So let me put a could there. So you could use the quadratic formula if you want. So that's an x squared. We got an x and an x. That's a positive 45, so both of these will be negative like the middle. Factors of 45 that equal 14 or 9 and 5. And then you take these factors and set them equal to 0. But y'all, all we're doing now is changing the signs from the linear factors back to the zeros. And if you remember a while ago, when you had to write linear factors, you took the zeros and wrote them with the opposite signs, okay? All right, so I get an x equals 9, x equals 5. But y'all, like I said on that, and you could have said, hey, let me go to program. Let me go to quad. Enter. I could have put a 1 for my A, negative 14 for my B, 45 for my C, and it would have gave me that 9 and 5 that I got, okay? All righty. So now we're going to find the domain of each. We're going to write in set builder notation. And interval notation. So we're going to write these both ways, okay? So the first one I got is a f of x equals 6x minus 5 over x plus 4. So the main thing we know is that we're going to play with the denominator here. So we're going to take that x plus 4 and set it equal to 0. So I just got one variable here, so I'm just going to subtract 4 and get this one done. So that x equals a negative 4. So I'm going to write that in set builder notation. So it'll be x such that x is a real number and x is not equal. So they're going to put some of these up, and they'll have one with an equal sign. Instead of a not equal sign, we need the one with the not equal sign, and then we just put in our negative 4. So be careful on that, okay? And then some of them will say x is just a real number. Now, interval notation is when I use the parentheses. So interval notation, you're going to start at negative infinity. From negative infinity, you can go to negative 4, but you can't equal negative 4. So remember, we're going to union around that negative 4. And then from the negative 4, I can head off towards my positive infinity. So that one we've already sort of been doing stuff like that. The new one will be these ones that got the x squareds on them, okay? So here's the next one. We got g of x equals 9 over 3x minus x squared. You also the same thing, take that bottom, set it equal to 0. Now what I'm going to do on this one, I'm going to rearrange it and put the x squared first so that I got a negative x squared plus the 3x equal to 0. Now, we're going to hit this with the quad. So the quad formula for this, A will be a -1 because that's a negative A squared. B will be 3 because that's the X term. C, since we don't have a number at the end, will be 0. All right, so then we hit enter on the quad. We put a -1 for the A, 3 for the B, 0 for the C, and I get 0 and 3. All righty, so for my set builder notation, X such that X is a real number, and X cannot equal a 0 or a 3. Interval notation, we start at -infinity. And remember, you got to go left to right, so my numbers need to go in the right order. So I'm going to hit 0 first. Union around my 0. From 0, I travel till I hit the 3. Union around that 3. And then from 3, I head towards positive infinity. All right, then we're done on that one, okay? Anyone got a question on that?
Why did we have to do 3 to positive infinity?
What
Oh wait, I see it. I see it. Never mind.
Okay, you got it? Okay.
Yeah.
All right, so one more. This was a sort of short section. So that takes care of them. All right, so this one, y'all, has a lot on top. F of X equals X to the third minus X squared plus a X plus a 4 all over X squared plus 13X plus 36. I will say, although they got a lot on top, we don't care because all we're worried about is that denominator, okay? So I'm going to take the bottom and set it equal to a 0. All right, so since I got a quadratic equation, I'm going to use my quad formula again. A will be 1, B will be 13, and C will be 36. But y'all could have factored that. There's factors of 36 that'll add to get you a 13. All right, let's see what we got. We had a, let me put a calculator over. For my A, I had a 1, B was 13, and C was 36. When I hit enter, I get what, a -4 and a -9. Alrighty, now on this answer, they want you to put X such that X is a real number. Whoops, number. And X not equal to my two numbers. But y'all, it says put in ascending order. So what they mean, you need to have these numbers from the smallest to the biggest in that order. And the smallest number between the -4 and -9 would be the -9, and then the -4. They're doing that on that one so that when you do this interval down here, you got them in the right order. But just remember on that, and you got to be in the right order, okay? So interval notation, we're going to start at -infinity. Going left to right, the first number I hit would be the -9. So I'm going to union around that -9. From -9, I go until I hit the -4. I'm going to union around that -4. And then from -4, I head off towards positive infinity. All right, y'all, so questions on that? So it's pretty much another domain like y'all been doing, but now they're really wanting y'all to use the interval notation some instead of just this set builder, okay?
And then we only put it in ascending order if it's a negative, correct?
Yeah, they just want y'all to get into practice of ascending order. They mean going from smallest number to the largest, and descending order would be from the largest number to the smallest. But I think they mainly just did that on that problem so that when y'all got down here to the intervals, y'all didn't put the -4 first and then the -9. They wanted you to realize that that ascending order is exactly what's going to match up on your intervals down here, okay?
Okay.
Alrighty, so 8.5 is actually rational functions. So we will get a start on this, but we won't do much. Pretty much definitions and stuff after I do the first problem, okay? So check this out. Look what the first problem in here is. Determine the domain. Every time you see rational, think fractions. Alrighty, so this one I just got an x squared over 10 minus x. So to find the domain, I'm going to set that bottom equal to 0. Now, I'm going to solve this one, but I think to solve this one, I'm just going to add an x to both sides and be done. Now, you could subtract 10 from both sides and then divide by the -1 eventually, but that'll take you 2 steps when we can do this in 1 step by getting our 10 equal to our x. All right, y'all, so the domain on these just wanted me to write them in interval notation. So the interval notation would start at -infinity until I hit that 10. Then I would union around that 10 until I hit positive infinity. So 8.5 started out doing what you did in 5.1. All right, y'all, so now some definitions. So I wanted to get these definitions out of the way before we come back on Thursday. So the first word we're looking at is a vertical asymptote. Oh, okay, those are some nice words, right? So a vertical asymptote is an imaginary vertical line that the graph cannot cross and they occur where rational functions are undefined. They come in the form of x equals some number. So remember, since they're vertical lines, they got to be x lines, okay? So I think I got a picture here. Let me put up here. I'm going to put a picture up here so y'all can sort of see these vertical. So on this picture here, this little dotted line going down through here, that means that this function was undefined at that x value, and this graph cannot cross over the line. So what happens, on one side of the line, it'll head down towards -infinity. On the other side, it'll keep heading up towards positive infinity, but they never touch each other. They just keep going up forever. They get really, really close to the line, but they cannot cross over it, okay? And then that'd be happening right here also. This side would keep going up, and then this side would keep going down, okay? So since they happen where functions are undefined, to find them, we set the denominator equal to 0. So we find a vertical asymptote just like we found a domain, okay? All right, y'all, then we got horizontal asymptote. Hell, I don't know if I say that right. Asymptote. Sound good to y'all, right? All righty, y'all. So a horizontal asymptote is sort of like an imaginary horizontal line that the graph tries to approach over time. So they're saying the more those x's get bigger and bigger, these try to tend to get towards a certain number over time, okay? These come in the form of y equals some number. So since they're horizontal, it depends on the y's, okay? Now, to find horizontal asymptotes, we look at the degrees of numerator and denominator. Now remember, the degree is the highest exponent, okay? So you got 3 cases that can happen. Case number 1 is the top degree is greater than the bottom degree. So that means on my fraction, my top's got a higher exponent than the bottom. If that happens, there is no horizontal asymptote. Because if the top's got a higher degree, your graph is just going to keep heading up towards positive infinity. However, if the bottom degree is greater than the top degree, so it's bottom heavy. If it's bottom heavy, then your horizontal asymptote will be y equals 0, which means the graph over time is going to try to get right down to the x-axis. Case 3 is the top degree equals the bottom degree. If that happens, y will equal the ratio of A over B. A is lead coefficient on top. B is the lead coefficient on the bottom. So for a horizontal, we look at the degrees, and for a vertical, we set the bottom equal to 0. So I'll show y'all maybe an example of each of those so that y'all know what I'm talking about on them, okay? All right, anyone still writing this?
Yes.
Okay, I'm gonna give y'all a second then. And that's also what I
Can
like
you
about
pull it up
recording
a
it,
little
because if
bit?
any of y'all messed up on the notes, I'll be sending a video later on this, okay?
Okay.
All right, y'all ready, Josh?
Yeah, go ahead.
Okay. So I'm going to do an example of the vertical and then show you what the horizontals will look like. So I'm going to find the vertical asymptote. So we're going to call that a VA, okay, of the function. So they give me f of x equals x minus 2 over x squared plus 6x. So remember, it told me to find my vertical asymptote. I take the bottom, x squared plus 6x, and set it equal to 0. Now to solve that, I'm going to use my quadratic formula again. Remember, a is 1, b is 6, and c is 0. Because remember, I got the x term, which is my b, right? So let me quad that real quick. Enter, so I had what, a 1, 6, and a 0. So I get 0 and negative 6. Now, they want these answers in the form of an equation in MATLAB. So in MATLAB, you have to actually put x equals 0, comma, negative 6.
Okay.
Okay? If it doesn't like that answer, you may have to come in and go x equals 0, comma, x equals negative 6. But I think it takes it the first way I done it.
Okay.
Okay? So that's all you're doing on the vertical asymptote. You're just basically solving it and then writing your answers with the x's in there, okay? Now, we're going to find the horizontal asymptote. So f of x equals, oh, let me start out with this. And how about it? X squared minus 8 over 4x to the 4th plus 5. So the degree on the top equals a 2. The degree of the bottom equals a 4. So the bottom is greater than the top on this one. And remember, on that chart I showed you, if the bottom was bigger than the top, it went off y equals 0. Which means over time, this is wanting to try to get up to that x-axis, okay? But it never does get there. And I'm going to show you a picture of something like that. Y'all see this? So the horizontal asymptote would sort of be like this one. This graph is coming along and it's trying to get to the x-axis, but it never does get right on it. It just keeps going out and out on that, okay? Just like this one, it's coming up, it's getting close, but it actually never does cross those x-axis. All right, one more of these, and then I think that'll be it for these for today. So this one, we're going to have f of x equals 3x to the 4th plus 4 over 5x to the 4th minus 2. So let's see, the degree on top is going to be 4, because that's my highest exponent. The degree on the bottom is going to be 4, because that's my highest exponent. So these ones match. So since they match, it's going to be the ratio of A over B, where A was the lead coefficient on the top, which is 3. B is the lead coefficient on the bottom, which is 5. So we get y equals 3/5 as our horizontal asymptote.
Okay.
Hey, y'all, so those are not too bad. But there's more work on them, and we'll actually cover 8.5 in our next class, because we'll actually look at how they graph these and all that using those asymptotes and stuff. Okay. So,
All
y'all
right.
have any questions?
No.
All right, so I'm going to stop my share and go back to my regular screen. All right, I'm going to actually stop recording this now.